Okay, this is a video that's going to cover surface area of pyramids. I have a second video that will cover the cones. The warm-up here is saying that we have a semicircle with the vertices at 2, 5, and 2, 9. What three-dimensional figure is created when this semicircle is rotated about the line x equals 2? Now, it being rotated is just asking you what three-dimensional figure. It doesn't matter, honestly, what the vertices are at, nor what line it's rotated around. A good thing to do with this is to remember the what two-dimensional figures will create what three-dimensional figures. The three-dimensional figures that we will talk about here is going to be the cone, the cylinder, and the sphere. The reason it's just these is because these are our three-dimensional figures that are circular. A cone is going to be formed when we have a triangle rotating around a line. The cylinder will be a rectangle, and the sphere is going to be a semicircle. So we can already look at which three-dimensional shape is going to be formed. We're looking at a semicircle. Semicircle is going to form the sphere. Okay. Now let's go ahead and talk about the parts of the pyramid. A regular pyramid, all the faces, so all the lateral faces, not including the base is 1, then we got our faces, are going to be congruent isosceles triangles. Okay, and if we can see all the way around, and we're only going to have one base now, we'll talk about in a minute. The vertex is going to be the point where all the lateral faces are going to meet. You can see right here, the vertex is where if you're running with the figure, you don't want to fall, you don't want to trip and fall on that point. Okay, the altitude or the height. Okay, the altitude or the height is going to be a segment. It's going to go from the vertex. It's going to be perpendicular to the base of the figure. Okay, big thing is perpendicular and base. When we look at a three-dimensional figure and we take a look at what it looks like with an actual figure that I have here to show you, this is where the height or the altitude is, this little pen that I have here. Okay, notice it's coming out of the base, goes straight up here to the vertex. Make sure I have my colors coordinated. And we're going to go ahead and put over here that the altitude is the height, which we should already know. And it is represented with this little lowercase h. Next, we're going to have what's called the slant height. And this is like an italicized / cursive L. The slant height is going to be the height of the lateral face. Remember, the lateral faces go around and meet up at that vertex. So I have two different things to show you. One is going to be a net, which is a flat two-dimensional diagram of a pyramid. If we were to lay it out flat, this guy right here, you can see it in this picture here, okay? If we take a look, when it's flat, we've got this triangle because we said that we're going to have lateral faces or congruent isosceles triangles. And we look at just the face, we're looking at, here's the height of the triangle on the inside. When we put them all together, you're going to notice, that I'm going to do this the best I can, it's going to actually slant downward. This is the best I can do, guys, sorry. It's going to slant downward on the outside, so it's like a slide. Okay, so in this diagram, it's going to go from the vertex, the slant height slides down the side. A lot of S's there, okay? And so right here, next to the slant height, we'll go ahead and put this little cursive or italicized L. And then on my three-dimensional figure, we're going to see it drawn right here on the outside. Again, it's going to slide down the side. Now, the next section explains where the lateral surface area comes from. And lateral, we do represent with an uppercase L. Okay, it's going to be one of the surface areas we're going to find. I'm not going to go through and explain all of this, but I'm sure you can search on YouTube a video that explains it if you really do want to know how we get our final formula, which is big L equals big P. That will be a slant height L. over 2. But we're just going to go ahead and talk about what the pieces mean. The P is perimeter of the base, right here. The little L we already talked about is that slant height slides down the side, and then we just put it over 2. Again, sometimes you'll see 1/2 big P slant height. So let's go ahead and take a look at some problems. Okay, so here, go ahead and at the top of the paper, make sure we see big P is perimeter of the base, big B is going to be the area of the base. Now the L is going to stand for lateral surface area, which you notice does not have a big B because it does not carry it does not contain the base. And then S will be your total surface area, including that base. Just take a quick moment to pause and write all of that down. So for these 3 problems, what we're going to do is we are going to find both the lateral and the total surface area, and when needed, we are going to round to the nearest tenth. Okay, so let's go ahead and take a look. We've got this broken down. We're going to first name the shape of the base. We're going to find big P perimeter, the slant height, big B the area, and then we'll go ahead and plug in to our formulas and get our answer. Okay, the shape of the base, it only has one length right here, okay, and I will go ahead and let you know, because they're not giving us the other second dimension, that this will be a square. So the perimeter of the base, we take a look at the base here, okay? We have 4 sides at 10 each. So our perimeter will be 40, and I'm not going to worry about the units until the very, very end. And then your slant height, sliding down the side right here, is going to be 13. And then the area of the base, remembering with our area, it is base times height. So 10 times 10, or you might use side length squared. Your base is going to be 100. So now when we plug into our formula up here, we are going to have in fraction form all over 2. We're going to take big P, that perimeter of 40, times the slant height of 13. And then we plug that all into the calculator, and we end up with 260 units squared. Again, we are still dealing with surface, even though it's 3-dimensional, it's the surface area. So we are still dealing with units squared. All right, S for total surface area, we're going to start off with the lateral part, the 40 times 13 over 2. And now we're going to add in, again, we only have a single base in pyramids, so we're only adding a single big B. And we end up with 360 units squared. Next, we're going to have to do a little side work here, okay? We have a regular triangular pyramid, meaning the base is a regular triangle. We need to remember regular polygon means all sides and angles are congruent. So it means all 3 sides. They even gave us these little tick marks, okay? And the base edge, what they're talking about with the base edge is going to be the base's side right here, okay? That entire thing is going to be 24. And we have a slant height of 16. So let's find where the segment slides down the side. And this right here is going to be 16. So right now we can go ahead and plug in for slant height 16. The shape of the base just told us triangle. So let's go find the perimeter. The perimeter being a regular polygon, all 3 sides are the same. So we have 3 sides at 24 each. Your perimeter will wind up being 72. Now the area of the base. The area of the base, because the base is a triangle, we're going to need to do base times height over 2. And the problem is we have our base, but we don't have our height. If we draw in the height looking at just the triangle base, we need this height. So to find that height, let me go ahead and outline the whole triangle that we're looking at here. We're going to go ahead and draw this triangle to the side. Okay? Keeping in mind the height right here, this is what we're looking for. Down here, this little portion is right here. That is half the side length at 12. And then when we look across the 90-degree angle, we have another side length here of 24. So we will complete our Pythagorean theorem, noting that 24 is going in place of c. So we will have x squared plus the 12 squared equals your 24 squared. Okay, we're going to square both numbers we have. And we need to move the 144 over to the right by subtracting. And I'm running out of room. And then the last step in Pythagorean theorem is always to take that square root. And thank goodness I can write small. It said at the very, very top, we're going to run everything to the nearest tenth. So this will end up being 20.8. Okay, now this is only the height of the triangles, the triangular base. So for big B, base of 24 times the height we found, 20.8, over 2, and we plug everything into the calculator, run it to the nearest tenth, 249.6. So let's go ahead and take a look at our formula and let's plug in perimeter times slant height over 2 for lateral. So we have perimeter of 72, slant height of 16 over 2. We will wind up with 576 inches squared. This one did give us the units. All right, and again for the total, all we need to do is repeat the lateral part and just add one of our big B's onto that. So let's go ahead and fill that in. Plus 249.6. Everything plugged into the calculator will give us 825.6 inches squared. Pause it if you need to, rewind if you need to. The last one, we're going to have a regular hexagonal pyramid, okay? So we got a regular polygon. The good news is we do not have to go find the apothem and plug it into the formula, because what they have done is they've already given us the area. Base area is the area of the base. So we can just go over here to big B and type in, write in 93.5. They've given us a base edge of 6. So that means, I know the lines on the edges right here don't really line up. It's all right. This is going to be 6. And then our slant height of 14. So we can go ahead and plug that one in. Looking at our slant height is right here. And as they told us, we have a hexagonal pyramid. So the shape of the base is a hexagon. Pyramids are named after the shape of their base. So this one's going to go pretty quick, guys. Let's go ahead and find the perimeter. Well, hexagonal is 6 sides, and the side length is 6. So your pyramid, 6 times 6, is 36. All right, let's plug in. Perimeter times slant height over 2. Goes in the calculator, we get 252. Our units are at centimeters, so we have centimeters squared. Total, repeat what the lateral is and add one of the big B's. So, repeating this part. And then adding in a 93.5. We are almost there. Plug everything into your calculator. We're going to get 345.5 centimeters squared. You can search, if you want to see more problems, you can go ahead and search YouTube for it. I know that I've got some other videos up there as well from previous years. Ask your teacher if you have any further questions.